about the distance formula. So let's say we have 2 points, -2, 1, and 3, 5, and we want to know the distance between these 2 points. So this distance right here. Now, there's a formula that you will get at the end of this video, but I'd like to motivate the formula because the formula is going to look a little bit messy if you don't know where it's coming from. So without having a formula, do I have the tools to find the distance between these 2 points? And I'm going to argue that you do. So super tricky here, but let's make ourselves a right triangle. We're going to make ourselves a right triangle. Pretend it's a right triangle. It got a little wonky there. Where the distance is the hypotenuse of this right triangle. We have x and y values of both of these points, so we can figure out the length of each of these legs of the right triangle. And if we have the length of 2 legs of a right triangle, we can use the Pythagorean theorem to find the length of the hypotenuse. As long as you have 2 sides of a right triangle, you can always find the length of the third. All right, so here, this distance from 3 right here, we have -2 over here. This distance, there's 2 here, 3 here, this is 5. Really, if you want to do it the right way, we should be doing 3 minus -2, which is 3 plus 2, which is 5. But the length here is 5. Up and down, we know that this y value is 1, and things are a little messy in here, but this y value is 5. So this distance here is 5 minus 1, which is 4. Okay. The distance between 1 and 5, this distance here is 4. So we have this, more or less, this right triangle. We have 4, we have 5, and we have this distance d that we're trying to solve for. The Pythagorean theorem is a squared plus b squared is equal to c squared, where c is always the hypotenuse. I'm going to let a be 5, so we have 5 squared, b will be 4, plus 4 squared is equal to c squared. We have 25 plus 16 is equal to c squared. Let's see here. We have 41. Did I really choose a not nice number here? I did. Okay. We have 41 equal to c squared. In order to get c by itself, we need to take the square root of both sides. So the equation 41 is equal to c squared. We solve by taking the square root on both sides. If you don't recall, the square root of c squared is plus or minus c. This works with any variable. The plus or minus is used in almost every circumstance, but when we're talking about the length of a triangle, lengths are always going to be positive numbers, so we're not going to do the plus or minus here. We're just going to say that the square root of c squared is c. We have square root of 41 is equal to c. So c is actually d, I guess, or let me erase this. Let's call it c. So the hypotenuse, which is the distance, right? This distance right here is this distance here. The distance between the 2 points is the square root of 41. Something important that I would like to point out at this step right here. When you have this 25 plus 16 equals c squared, notice that I did combine them into 41 before taking the square root. It's really important to do that. if you were to take the square root like this, which is still valid, this is still valid, what tends to happen is students try to break up the square root like this and distribute it over the addition sign. And you cannot do that. You cannot distribute a square root over addition. So if there is addition on the inside of a square root, you do have to simplify those first, even if it comes out to a not so nice number. You cannot say that the square root of 25 plus the square root of 16 is equal to the square root of 25 plus 16. So let's try to generalize a little bit here. I'm going to draw just a very generic graph here. And let's say we have 2 points. This point down here, I'm going to call x1, comma y1. Those are subscripts. And we will call the second point x2, comma y2. We want to find a formula for the distance between these 2 points, which I will call d. Again, we are going to draw ourselves our right triangle, but this time with generalized points. So the distance here for this leg of the right triangle is going to be the upper y value minus the lower y value. So y2 minus y1. Down here, the difference in x values is going to give us that other leg of that right triangle. So x2 minus x1. Now, if I pull that triangle over to the side of it, this side here is x2 minus x1. This side is y2 minus y1. And this side right here is d. I'm going to go ahead and explicitly label these in terms of A, B, and C in the Pythagorean theorem. So I'm going to call this side A. I'm going to call this guy B. And then D has to be our hypotenuse, so that would be C. A squared plus B squared is equal to C squared. So we have x2 minus x1 quantity squared, plus y2 minus y1 quantity squared is equal to c squared, but that's d in our case, d squared. We're trying to solve for d here. So we are going to take a square root over everything. Let me go ahead and just copy this line here. I wonder if I can change it all to black. There we go. I'm going to take a square root over here, a square root here. Again, the square root of d squared, we're just going to call that d, and that will be what we were trying to solve for. So the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared is equal to d, and that is our distance formula. Between 2 points. Let's go ahead and use it in an example. All right. So we're going to use this distance formula to find the distance between the points -2, 4 and 1, -6. It doesn't matter which point we choose to be x1, y1, and which one we choose to be x2, y2, as long as you are consistent. So if I take this first point and I call it x1, y1, and I take the second point and call it x2, y2, then we have x1 is equal to -2, y1 is equal to 4, x2 is equal to 1, and y2 is equal to -6. So calling this one x1, y1, this one x2, y2, you'll get the same answer even if you call these guys 2 and these guys 1. Here is our formula. I am just going to duplicate it because I am lazy. Okay. And now plugging in the values. So x2 is 1 minus x1 is -2, quantity squared, plus y2 is -6, minus y1 is 4, quantity squared. We're just going to simplify. 1 minus -2 is 3. So we have 3 squared, plus -6 minus 4 is -10. So -10 squared, all under the square root. 3 squared is 9. -10 squared is 100. So we have square root of 109. And that would be our answer. Some answers might have you round. So if it has you rounding, if it asks for your answer rounded to, 2 decimal places, then you would put it in your calculator and round the answer to 2 decimal places. But I'm just going to leave this as my answer for here. Bam. Again, you're just really using this formula right here to find the distance between them. Just be consistent with your x1, y1. So don't make it x1, y2. That will mess up your formula. But as long as you're consistent, it doesn't matter which you use. Just use this formula. And I'll see you in another video.